We have 13, 14. Second 8 weeks. 10, 27, 25. This is chapter 1, section 2. Functions and graphs. Since we're going to be dealing with a lot of equations, we first have to look at what does the term function mean. Function just means just that. It's an operation of some sort. But instead of having equations like we used to, since the only variable in there that the x is what's called an independent variable. It's independent because I can't do anything until I define what x is. Once I define what x is, then I plug it in there and it can tell me what the y value is. So x is independent. It can be whatever it wants to be. That means the value of y has to wait for x. So it's dependent. It's a dependent variable because you can't tell me what y equals until x is defined. Right. So instead of writing this, instead of y, we call it that. That's a function notation. This is the function name. And this is the independent variable. So the reason this is so cool is because I can't do anything with this. If I give you this equation, I have to tell you x equals 2. And you can put it in there. But with this equation, this is the only variable in the equation. Once I define it in here, once I do that, then I know anywhere I see an x, I put a 2 in its place. And I keep on doing it. So whatever I define, this is where I define my variable. That's my x. So I go to the function name f. Here's the function name f. It equals that. So it's 3x is 0. So 3 times 0 is 0. The answer is 2. These are still points on a graph. This is the same as the y value. So x is 0, y is 2. It's still a point on the graph. Here, x is 2, y is 8. They're points on a graph. Now, that's what a function notation looks like. Functions must be 1 to 1. We could also write it this way. 1 to 1. What that means, if it's 1 to 1, for each value of x, there is one and only one value of y. That's what defines a function. By its 1 to 1-ness. So if we look at the x values here and the y values here. So I have x1, x2, x3, y1, y2, y3. So each x value goes to one and only one y value. That's a function. X1, x2, x3, y1, y2, y3. Is that a function? Yes, it is. Because each value of x only has one arrow. It doesn't have to all go to the same person. Kind of like if these are students, this is their teachers, they all give it to one teacher. These are my x values, these are my y values. Well, let me give you these names also. The x values, the values from the x's, we call the domain. The values of the y, we call the range. So we're using those terms a lot. X's and Y's, ranges, domains. So these are examples of functions. X1, X2, X3, Y1, Y2. Now, what if we have this? Is that a function? No, not a function. Because there are two lines for this one value of X, there are two values of Y. That's not one-to-one. One-to-one is for this one, it belongs to only one Y. This one only belongs to. This is not a function, but it is a relation. And this is they use these terms for a specific reason. We use the term correspondence. For example, correspondence. In the old days, they used to call mail that you sent by mail was correspondence. Why? Because one person from one house wrote a letter, sent it by mail to one person in another house. So that's correspondence. It was a one-to-one correspondence. But then a business could send out magazines to multiple people, multiple houses. It's no longer a one-to-one correspondence. Now they form a relation between the business and the customer. Which is kind of the same thing as relationships. A relationship is, if it's a one-to-one relationship, then they correspond to each other. Husband, wife, boyfriend, girlfriend, and so on and so forth. But a relationship, you're not tied down. One person could have multiple friends, multiple relationships. So that's how it all works out. So let's see what it looks like mathematically. These are all points on a graph. Whenever you see these little squiggly lines, that represents that anything inside there is a set. Anything inside these squiggly lines is a set. Now, is this a one-to-one relationship? Is this a relationship, or is that a correspondence or one-to-one correspondence? Is it a function or not, basically? Well, the easiest way to do it, if all x values are different, then it is one-to-one. It is a function. So all the x's, they're all different. Is this one-to-one? Yes, it is one-to-one because each x value belongs to only one y value. They're all the same. These are all the same points. We have problems. Is this one-to-one? Is it a function? No, because these two x's are the same and the y values are different. So not a function. Okay, so that's how we can tell whether it's a function or not. On a graph, since if all the x's have to be different, if they're all different, then what's going to happen here when we draw a graph, no vertical line will touch more than one part of the graph. Is this a function? Well, if we drew a vertical line on the graph, if each line touches the graph only one time, then it is a function. Likewise, this one. If I draw a graph anywhere, the vertical lines, they touch only one place. So this is a function. This one is a function. This one, not a function. This is called the vertical line test. If you could draw a vertical line anywhere and touch the graph more than once, it's not a function. Let's see. Let's look at these examples. Again, here's the graph. Can we draw a vertical line and hit it more than once? No. Each vertical line only touches it once. This one, it fails. This is not a function because it touches the graph 3 times. This is not a function because the vertical line touches it twice. This is not a function because it touches it twice. This is a function because it touches the graph only once everywhere. This one is a function also, because even at this point here at -1, see how this one's open and this one's closed? That means this is the only point it touches. This one's not going to be touched. So that's what we're looking at there. Vertical line test. Finding domains of functions. Find x values where the function is undefined. Okay, what does that mean? We have to go through a whole bunch of rules here. For the first off, if we had the function 1 over x, what's the only x we cannot use there? Well, the only rule we have here is you can never have 0 on the bottom. So x cannot be 0. So the domain is from -infinity to 0, and then from 0 to +infinity. Okay, the question is, what if we had f of x equals 3x over x plus 2? Again, it doesn't matter. The top of a fraction can be positive, negative, or 0. So there's no, in this case, there's no restriction for it. The only thing we cannot have is the bottom cannot equal 0. So it equals 0 when x is -2, the bottom 0. So x cannot equal -2. So my domain is from -infinity to -2, and then from -2 to +infinity. So that's with fractions. The other type of equations that it'll make more sense when we look at the graphs later on. The square root of x. What's the only rule we know about square roots? Square roots inside here, you cannot have a negative x inside there, or a negative number. Whereas a square root of -4 doesn't exist. Not a real number, I said. Not a real number. Because no two numbers, the same number, equals -4. -2 times -2 is a +4. +2 is a +4. So it doesn't have one. So that means the smallest number that can go inside there is x can be positive, any positive number, it could be 0. The square root of 0 is 0. So the domain is x is going to be greater than equal to 0. And we'll look at all those later on. Because we have a whole, but we have a couple of charts we have to look at for knowing what these graphs look like. So don't worry about these just yet. So if I give you a graph, or if I give you this graph, what's the domain? In other words, remember, I'm looking for the domain. What are my x values of this function? So looking at this graph, the smallest I can have is -3. So it starts off at -3 and it goes all the way up to 5. It's an open circle, so it means we can't use it. It's a closed circle. We'll go over this later on in section 6, so don't worry about it. So that's what that domain is. The domain of this one, because look at the ends. These are points. These are dots. So they stop there. But these arrows mean it goes on forever and ever. So it keeps on going forever this way and forever this way. So it's from -infinity to +infinity. All right, so it's 8 o'clock. We'll call it an evening. We only did 2 sections there. So that's the end of that section. We'll pick up next week. We'll do section 3. And then sections 3, 4 will go pretty quick. 5 and 6 will have to go together. So we'll try to do as much as we can next week. And then I guarantee once we get going in this class, once we get past chapters 1 and 2, we'll have more of a background, an idea of what's going on, and then it'll speed up much faster. Any questions? No questions? All right, then. If there aren't any questions, then we'll call it an evening. So try to do your work as fast as you can. Look at the videos. Try to move ahead so we can move a lot faster. Just watch my videos online and try to pick up as much as you can, and we can ask questions during class. All right, have a great evening, and I'll see you guys next week.